Okay. Hello, everybody, and welcome to our third day of Introductory to Python. So before we start agenda for our today, our last day, let's recap what we did so far. So first of all, I want to remind you only about the most important concept from our day 1 and day 2. And the first one is to remind you that in Python you have variables that you can declare, store, which you can use and change. And there are 4 main basic types of variables. One is string, which hold your text. 2 numeric variables. One is integer for whole numbers. 1 for floating points, and Boolean variables that we use to mostly for alternation of the code in if-else statements. So the second concept we talked about is making decisions. So in here we use our boolean. So here in example, you can see that I have a boolean which says me, is it snow
we
outside?
can't because you're not sharing the screen.
Yeah. Share screen. Sure.
Now it's good. Yay.
Now it's good. Yeah. So here is a recap about variables. So I have showed you 4 examples, one for each data type. So it's string, integer, floating point, and Boolean. And see that in Python, you declare your data type by using specific literal. So for integer, you just put number. If you want to have a floating point one, then you need to use a comma here. For Boolean, there are 2 options. One is true, another is false. And here's my example with my code where I make a decision. So there is, I declare the variable, is it snow outside or not? And if it's, I set it to true. And here I have my decision that I can make using if-else statement. So, and if it's snow outside, so I want to stay home. If it's not, I want to go to work. And so you see that because it is snow outside, I set it true. So my program says me that I have to stay home. The main concept, so important note is about indentations. So when I make some decision, I want to use if statement, and inside if statement, I won't have several lines of code, for example. One line of code, another line of code, third line of code. So if statement should understand somehow where this body of the if statement ends. And for these purposes, I remind you that we use indentation. So let me show you how it might work. So I have 3 lines of code. Okay. And I set my if statement to false. So first, let's see how it's worked with true. So everything is going to be printed. And if the statement is false, nothing is going to be printed, right? Because if understand that everything, because of these indentations, it understands that all 3 lines of the code belong to the body of if statement. If I remove indentation, then the body of the code consists only of 2 lines, and third one will be implemented in any case here you go. Okay. What else? We also talked about how to repeat code in the loops. We have while loops and for loops. So while loops called this indefinite loop. If we don't know how many iteration, if we don't know in advance how many iteration we are going to have, then we use while loop. So it can be ways with variables. So here is, I have a test variable, which is I, and I check inside the while loop if it's less or equals than 10. And if it's true, then we do something. And inside the while loop, I have not to forget to do modification of this variable, because if it doesn't change, while loop will go forever. Another option is to use break statement inside while loop. So we use it, for example, when we asked user for input and we have some encryptic symbol like empty line when we don't want to speak with user anymore. So we can catch that in if statement and then break the implementation of the loop. And the second one is for loop, when we know in advance how many iterations we need to do. So for example, if we have some collections, and here is range, a function that creates collection for us, and we know in advance that this for loop is going to go from 1 till 11 with till 10, because 11 the stop parameter is exclusive. So with step 2, and we can even skip some states by using continue rule. So here in this for loop, we're interested only in printing numbers that are divisible by 3, and therefore we just omit all other iterations using continue statement. So here was a question about this example on our previous slide, and the question was why do we need the print statement and then. So, and it is a good question. Remember about the concept of indentation. So we have two for loops here: inner outer loop for loop and inner for loop. And remember, this code is printing your multiplication table, right? So outer loop is responsible for printing each row. So there is 10 rows, and it goes from 1 to 10. And inner loop is responsible for printing cells. Okay. So, and since we modified printing here by setting end parameter with t /t, which is equal to tab, after each implementation, after each run of this printing, we don't start new line. Instead, we print tab at the end, right? So why do we need this print and why it's work? The answer is very simple. For this outer loop, the body is all these 3 lines. Why? So let's look how many commands this outer loop has inside its body. First one is for, with its entire inner body, which consists of just one string, right? So this is line number 1, this is for. And after that, since we didn't finish, since we still have indentation here, it also treats it as a body for outer loop. So outer loop consists of this line. This is for loop. So basically, we can treat this as one block, and the second line printing. So that's why this print works at every single ending of the line. So let's test it a little bit. Let's print something additional. So print something like end of the body. And let's see what will happen. So you see, at the end of the body, it prints this statement. If I remove indentation, it is going to tell that this one is outside of this outer for loop. Okay. So, okay. Do you have questions? Yeah, what is the difference between using /t and /n? Yes, exactly. /t creates /t creates tab. Just it simulates pressing of tab on your keyboard, and /n emulates the pressing enter on your keyboard. So both of them are special characters that's called escape symbols. So you can read, if you Google, you can find that there is a lot of escape characters, and you may find them useful to use inside your code. Okay, so next we discussed creating lists. So if we have some variables of a similar kind, like a set of friends, like here is in the example, we can add them to a list. And remember that list has a lot of properties. I didn't list them, like appending elements, accessing elements. Let me show it here. So for example, we have a list of friends, or let's say chars, list of chars, A, B, C, A, B, C. So what we can do, so we have here our characters. We can append another character to the end. So it's chars dot append, for example, D. Now it modifies the characters list, or you can access these characters by index. So let's access some of them. For example, the first one. Okay, so for example, chars, zeros, and basically, if you list has a lot of different functions, you can list all of them here. So, and for example, there is function sorting or inserting that I didn't tell you before. So that source, if you want to add element not to the end, but to something in between in the list, you can do it by using insert function that accepts two elements. First one is index. For example, let's insert after the first element. Let's insert capital A. So let's see what will happen. So we have modified our list now. Okay. The next one is we talk about how to read and write files. And I told you that I recommend you use viz command, which is basically, what is basically viz doing? It not exactly works with files, but it can work as what I'm basically doing. I'm creating some variables that works inside the body, just inside the body. So I can print A here. So, oh, it doesn't work. Okay. Oh, it should be some object, I believe. I just don't. And it doesn't work with literals. Oh, okay, I forget how it works. But with files, it works like we have a function that returns us an object, so of type file txt. So let's open it for writing. We know there are two modes. One is writing, another is reading. And let's print type of this object. Which is basically, okay. So yeah, now I understand what I forget about this function. However, outside of the body, it just destroys this object and closes this. So basically, there is a requirement to use this with operation that this object should have special properties and what I say. So it should have some special functions that with this calling on creating, on entering this body and exiting this body. So yeah, and integer doesn't have these properties. Okay, so basically what it's doing, why it's important to open file with this is that it closes this file when it exits this body. So here, this body is still working. However, when we exit the body, we cannot access our file anymore. And pass is just an placeholder for the commands that Python understands as a like a phonic command. So it is going to work. Okay. So what's next? Reading and writing files. So I said that you have two ways to open file. One is for writing, another is for reading. And when you open it in write mode, you can write to the file strings. When you open it in reading mode, you can read files line by line. And basically, this with OpenTXT is equivalent to open file in the reading mode. Yeah. Okay, so we can read file with this parameter R, or just ignoring them, it's going to set a default parameter. Okay, what's next? So here's our outline. So today we're going to talk about functions, sets and dictionaries, and about using libraries. And today I'm going to introduce your final homework and your final quiz. Okay, so let's talk about functions. A function is just a collection of code that is used to solve some specific task. After function is created, it can be called from another part of the code. So here I'm going just create a simple function like I have on slides for you, but here I'm going to tell you how to create it. So first, to define the function, I need to use the keyword def, which means that I'm going to write a function. So then after this def, I need to name this function. So I have a name. I want to call it say hello, and function definition requires this parentheses. Okay? So for now, I'm going to leave them empty, and later I will explain how we can use this parentheses. So inside the function, I also need to make indentation, and function ends when at the place where I remove this indentation. So, and my function is going to have to print comments for simplicity. So first it is going to implement the first one. So I will say hello. And I'm going to end it with a space just to stay in the same line. And the second one is going to say, for example, user. Okay. And here I have defined the function. So I have removed indentation or finished the block, which is equal to removing indentation. So now I have my function defined. Now I can use and reuse this function from my code. So I bring, say, hello. And I need to use this parenthesis just to say to say Python that I'm going to execute this function. So, and it is going to do that. Say hello. I can repeat my say hello. I can do some other stuff. And then again, say hello. Okay, and I'm executing the code and it's worked. Okay, so if I print a function without the parentheses, so it is going to say me that it's just an object of type function. Yeah. So basically in Python, everything is an object, even functions. Yeah. What's next? We have a question. The point of pass is it is just a placeholder. I have, okay. The one of the useful options, if you want, for example, if you create some program, you better to go top-down approach. And for, let's say that I'm here starting my script and I want to analyze my genome. And what I can do is to just, because I want my code to be split in small chunks, I can, for example, define a function which calls analyze genome. And I don't know now, I don't know yet what exactly is going to be here, but I want my code to be functional. So I just keep an indentation just to tell Python that it has some body. And at this point, it is just empty body. And then in other part of my code, I'm going to use these placeholders just to say that I'm doing here something. So do something, do something. And inside the code, I can use my analyze genome, which is not filled yet because I don't know exactly what I'm going to do, but on top level structure, I can already say that I'm going to have some function that is going to do some analysis, okay? So, and I can play button and it doesn't raise any errors. So another option, another useful moment is that, for example, in notebooks, there is a side effect. So when I print some literals, so for example, hello world, it is going to print it. So I am not going to dig into details why that's happened, but it has some meaningful properties. However, if I want to suppress this output, so basically the results of this chunk of code is the results of the last line. That's why it prints this hello world. So if I want to suppress this output, I want to just put pass, and I don't see the result. I don't see this result anymore. So when this chunk of block doesn't have results, it may be useful when we use multi-line comments. I will touch them a little bit at the end of the lecture. However, or it can be useful. For example, there is matplotlib functions that vary variables, so they return you some logs, something, and basically what happens. So instead of just seeing a picture on your screen, you see some log, and if you want to suppress this log, you just print. You just put pass here. Okay. This is about pass. So function can accept parameters. Let's see what I mean. So let's say that we want say hello not to user but to somebody, and here I can put a name somebody, and this somebody is a variable. We have a question. Comments with tendential block. Yeah. So another use of the pass is that comments that use intended blocks like for, while, and if require non-empty blocks, even if the program is supposed to do nothing. So pass is required in these cases. Yeah. I was talking about parameters for the function. So basically, I'm declare that each time when somebody is calling the say hello function, he or her they required to provide some variable inside the parentheses that can be used. So there is another question. Okay. So that can be used by the function. So, and we're going to use it. So here we use this variables, somebody, and we cannot use say. So let's load this function into Python. So, and see, now this function requires these parameters. It says that say hello missing required argument somebody. We can suppress it by set a default parameter like Bob. Now function is not required to pass anything. However, let's remove these default parameters and see what can we do with these parameters. We can, for example, we can send names now inside our say hello function and say hello to everybody, to different people. And our functions becomes more general just by adding one parameter. Okay. Okay. You can create many parameters. For example, and for example, set, and you can write a logic inside here. For example, if another person print or say person. Let's see what is going to happen. So now I have two parameters. I didn't compile it yet. I didn't load it yet. Okay. What is happening here is that I added another parameter and I set a default value for that. So now we can use these functions in two ways, with one parameter and with two parameters. So if I use just one parameter, it worked like before because it executes this hello, then use somebody. And since we didn't provide another person, it assumes it set it default parameters. I said that because our parameters can default values. So purpose. The question is, what is the purpose of this and equal equal space? So by default, print behaves this way. It prints. So let's use print twice. So by the default behavior of print is it puts end of the line at the end after it prints the content of the parameters. Okay, to suppress that, we can modify ending. So we can, for example, put empty string, and it's going to output two prints concatenated, or we can use other symbol, okay, or space. And basically, if we put and to /n, it's behave like normal. And what is basically happens that inside this print, it has variable and which has default parameter. So let me go to this a little bit deeper. So here you see two properties. So let's go to our say hello function. So now we know that it has two parameters. One of them is default. That allows us to call these functions in two ways, with two parameters and with one. With one parameters, we know what happened. So somebody will be equal to Alisa if we call this line, okay? And it prints hello to Alisa. And since we don't have another person and empty string is treated as false, we don't do anything. However, if we use both parameters, another person is equal to n now, okay? And this if statement is true, and that calls that implement this code inside if body. And inside if body, we use the same say hello with one parameters. And so you can see here very important property that we can recursively call functions out of themselves. Okay. Of course, we can call another functions, but we have only one function here. But we can call only themselves. So, yes, question is, so is empty line considered as a null string and will result in a false bool? Yes, empty, you can see that not only empty string, so let's, so I can check that bool of empty string is false. 0 is also converted to false, and zero float is also converted to false. And empty list is also false. Why does somebody needs a default value? It doesn't need a default value. We can remove this default value. But so, and it's technically work. So let me just comment out this too. Why I'm commenting out it because we cannot call it with one parameter anymore. So I just need to copy this one to copy these two strings and need to put another one, another person. It is going to work perfectly. However, I cannot run it with one parameter anymore. And you see the type error says that say hello missing one required positional argument another person. Okay. So, but if I add second parameter, it is going to work perfectly. Okay. Next, so let's return our default parameters and let's make both parameters for both persons. So let's return our code. Now we have a flexibility of we can even call an empty, say hello. Say hello with empty parameters because we have both parameters has default value. If we put one parameter, Sam, we substitute the first one because we fill them in order because they are positional. So, and what is also interesting, we can set up a second parameter without setting up the first one, just by naming them, and this is called named parameters. Okay. Okay. Any questions about functions so far? Why does somebody needs default while likeness? Does Python have pass by reference like C++? It's a good question. I would say that Python has only one option, which is pass by reference, because everything in Python is an object. But actually, except from, okay, everything is passed by reference, except maybe for basic types. We can easily check that, but I don't want to dig into this pass by reference and pass by value.
It is technically everything is passed by reference. Some references are pointing to values that are immutable, so you can't modify things.
Yeah.
So like, that's how it works.
Yeah. So in Python, there is a concept of mutability. So for example, basic value, you cannot change some values. And so it doesn't make sense to say, even to say about pass by value. But I don't really like this concept of pass by reference, of pass by value, because of another reason. Because how it works, it requires understanding of memory, of how memory works. And if you understand how memory is working, so there is a concept of a concept of heap and stack, right? And it ends up that in C++, in Python, in Java, actually everything is passed by value. Everything is passed by value. But why we talk about passing by reference is that reference is technically is a value, but with this value you can access as a memory, and that's why you think that it's like passing by reference. But what I like is so usually I explain this concept on my bigger lectures, and I'm trying to explain it from the point how machine is working. Okay, so I'm not going to go deep into these details at this moment. And let's say for Python that all objects that you pass inside as a parameters, that you can modify them, and these modifications will be seen outside if this object is mutable. Okay. And we will touch mutability a little bit today, but I am still not going to go to details much. Okay. So what is good about functions is that we can use so-called top-down approach when designing programs, as I tried to show you before. So if we think top-down, we can think about big solutions as a function. For example, I showed you that I have created a function for analyzing genome, even without populating it with any functionality. So that's called top-down approach. So I think in big pictures that I need to do some analysis. Then when I work on the function do analysis, I'm also thinking about it as a top. So for example, I need extract genome, I need to filter reads, so I also create for every single function some additional functions that I'm thinking from the top perspective. And it allows me to split a complex problem into small chunks of manageable, better manageable problems. Okay, So let's see how it works with our example. Suppose we have a list of friends, which is equal to, for example, Alice, Bob, Tom, David, for example, right? And we want to say hello to everybody. So how I'm going to approach this problem? So I'm going to write a function, like function say hello to everybody. And here I need one parameter, which is my friends. Okay, and I'm going to do pass here because I'm working on top-down approach, and here I'm going to use it. So say hello, so I'm going to load it to the system. So say hello to everybody and put my friends here. And it is working, right? But it doesn't print anything here. So here inside, I'm going to go to say hello to each friend. So for friend in friends, I use my functions that I have already written, luckily. Say hello and to my friend. And so you see here, I use top-down approach. So I start the problem with a big. I have created a function for this big task, and I use some function for very small task for saying hello to some person. So let's see how it works. Yeah, it worked. It worked fine. Okay. Any questions? Okay. And here's an exercise for you. So you need to print a function that called print triangle for printing the partner, and try to solve it with top-down approach. So you see that you need to create n rows, and it may be useful to use this function print row inside the print triangle. Okay, so take your time and start coding. Any questions? So what I recommend you is even if you don't know how to code. So yesterday I had yesterday I lost communication with my audience because I believe that some people do not start coding if they are not very confident and that they can accomplish this task. But I encourage you just to start coding, and I'm going to help you along the way solving this problem. So let's do a first part together that I expect you to be done. So you see here, in our task, we need to write a print triangle function. So I start with define. So print triangle. And I need some parameter n because you see pattern doesn't tell me till what number I have to print, right? So, and here inside, I need, I don't want to populate with this full code. I want to split to work in top-down approach. And what I certain is I need to have a cycle for E in range till N. And in this range, I want to print a row, print row. And which row? Row with index I. Okay. And I don't have my print row yet, so I need to create this function, def print row that accept index of the row. Okay. And let's just make it empty. Now we can load both functions into Python. And let's say how it works. Print triangle. And it accepts some n, let's say 5. Okay. It worked, but it didn't print us anything. So let's check at least our print triangle function. So let's print something. For example, print 1 or print I. Okay, let's load it again. And what it gives us now. So it printed 5 rows for us. Okay, now take your time to finalize this print row function. Okay, so what we need to do inside each row is we need to have another cycle for, okay, but I don't like this name. Let's call it again n as a parameter n, because I want to use E inside the cycle in range n. Okay, and I'm printing E plus 1, and I need to end it with a space. Okay, and at the end, I need to print an end of the line. Okay, let's see how it works now. It works perfect, except that it doesn't start with 1. It starts with empty line and doesn't end with 4. So how to fix it? We can just add 1 to our range in our print row function. Okay. So it works fine now. Okay, so let's have a break till 2:40, and we will continue our lecture. We have a question. Will it work with print triangle of 6? Okay, we can try it. Yes, it works. Okay, see you after the break. Okay, guys, let's move on. I have sent a link for the slides to the chat, so you can find it there. So we have 17 people, actually 15. So guys, how many, can you vote? How many of you are making exercises? So nobody is making exercises? Does anybody else trying to make exercises? Okay, good. Okay. Yeah, I think it's important to trying it, even if you cannot do that. So still during the lecture, it's important to try them because you gain your skills. So when I was student, I went to interview and they gave me just a sheet of paper and asked to solve tasks without using any computer and anything, and for language that I didn't know syntaxes well, and I was just trying to do my best to solve the task. Of course, I completely failed the interview, and I had two of them, and it wasn't. I didn't go to interview with the hope to get the job rather than to understand what the interview looks like. And I had two interviews, different companies on the same day, but on the second interview, I didn't have time to prepare. I just went from one to another. I was much more confident. So it was when I just starting my courses at university. So I recommend you just try your best, and that's it. Yeah, just difficult to learn Python in a few days. Yeah, that's exactly. Yeah, that's exactly. But at least, yeah, yeah, just to get an idea about mock interviews. So, and when I worked in industry, so I didn't know this concept of mock interview. So it was like, it was more than 10 years ago. So there was no such concept, at least in Russia. I have several major. I started at economy, and then I switched to math, mathematics, and then to computer science. Yeah, I have major, so in computer science eventually. Yeah. So, and what I wanted to say, yeah, I understand you. So it's really hard to get through the exercise, but at least when you're just thinking about that, how to solve this task on your own, at least you see your bottlenecks. So what you can feel what you miss, and when you're just listening, you may miss this point. Okay, so let's continue. Let's continue. So let's continue our slides. We have 2 hours, and yeah, here's our solution for our triangle. So it's in the slide, and here's another example. I already said you that we can call functions from themselves, and it's called the recursion call. And actually, it's very powerful concept. I can tell you that there are languages that use only they don't have variables. I mean, in the classic sense, they don't have variables. Of course, they have something because they still need to keep results and everything like that. But I mean that the ability to use this recursive call can substitute the traditional iterative languages. So, for example, there is Haskell language that is purely based on calling function. So it doesn't have variables in a classic sense. So you cannot initialize some variables. I mean that there is a shortcut to anyway to store results even in Haskell, but pure Haskell and pure functional programming that doesn't require variables and still fully Turing machines. Okay, so here is our. I mean Turing machines that they are fully equal to. The Turing complete languages, they are fully equal to Python, to C, to Java, and can solve the same task. Okay, so here's an example. There is Fibonacci numbers, so-called Fibonacci numbers, and there is a formula for that. So every next element is a sum of two previous elements, and because zeroth element is the first elements cannot be determined using this formula, so they are set in advance. So let's try to create this function to solve this problem. So we need to declare the function. I'm going to declare it as a Fibonacci, and inside I ask the index of this Fibonacci number. And since so basically the formula is a formula, and I need to create fib. I need to return value with just a sum of two previous numbers, and -1 plus fib and -2, and that's it, right? Let's try this one. Does anybody see any problem here? And let's just test it. So fib4, good. Yeah, it has a problem because maximum recursion depths exceed. So what is basically happened? Let's try to print the previous the results. So not the results, but try to print our index. What is happening is that numbers became negative very soon, right? So, and the problem is that we do not check when the function should stop. So, and the place where functions should stop is called base cases. So in Fibonacci number, we have two base cases because we need two starting points, some starting points. It is when n equal to 0. So we just need to return 0. And if n equal to 1, we need to return 1. Return 1. So, and other part calls recursive part. Okay. So now we have defined our Fibonacci numbers that should run. Okay. Let's try to use 20, for example. And does anybody see problem in this function? So what do you think? How efficient is it? For Fibonacci numbers, why do you have to use return instead of print? So we use return. Oh, and I didn't tell you about return anything yet. Oh, sorry about that. Okay, this is a good question. So basically, functions. What I forgot to tell you is that functions have a great property is that they can return the results. So, for example, I had an example for that. So let's return to say hello. To say to our say hello function, and let's define value who, and what we did is print hello plus who plus, let's say, exclamation mark. Okay, and it works perfectly. So we need to say hello to Sam, for example. Okay. Yeah. Sorry, I forgot to use literal correctly. Okay. But to increase its, but we can substitute this print to a return. And what now this function is going to do, instead of printing the result to display, it just tells function back about its results. So see what's happened. So now we can initialize other variables. So let's say content equal say hello, right? It looks less flexible, but in fact, the function became more general because now we can have content and we can decide what we're going to do with this content. So, for example, we can print it to log to the file to store it somewhere. While previous version of our function was just printing, right? So this is great property that function can return something. So, and basically this function has the results now that we can store in a variable, right? So here's another example. For example, if I want to create function for summing up numbers A and B, I can return A plus B, or my operation, whatever I like. Maybe I want to have return A squared plus B or something like that. So now I can use it inside print even. So my 2, 3, right? So this is all about return. So I have this in the slide. I just forget to tell about that. And here in my Fibonacci example, I have to use return because I need to proceed. I need to know the results of implementation of 2 calls of itself. Okay. So, and yes, this function is bad because it's slow. So we can speed it up by, so you need to think about that. So because if you track how many times we call this function, we will figure out that there is a lot of calls because we don't store results in the memory. So if we're going to do it more efficiently, we can store the results in some array and then use it from there. So, okay, this is good. And now an exercise for you: write a function write a function that compute factorial numbers. So, and n factorial is equal 1 to 2 to 3, 1 multiplied by 2 by 3, and so on till n. So you need to write two functions. One is with using loop, and another one is with using recursion. So try to think about that and solve it for 2 minutes, and then I will start solving it with you. Okay, so let's write a function that called factorial. So we need to start it with define. It's def, then factorial. Good question. Yeah, this is exactly the recursive call. Yeah. So let's first try to use for loop. So for e in range 1 and plus 1, and we need to keep a result somewhere. So, and by default, one of I wanted to say weird word, but like, so because we are multiplying, so we need to start with something, and we know that multiplying one by anything is going to give you anything. That is why this one is called neutral for multiplication, because it doesn't change the results after multiplication. So that's why I use this neutral element. Why do I need results? Because I need some accumulator or some place where I keep intermediate results. Okay. So, and here I just multiply my previous results by new number. Okay, and basically I need to return this value to the user. Okay? So and let's run it, and here is our factorial of 1 is going to be equal, factorial of 1 is going to be equal to 1, factorial of 2 is going to be equal to 2, 3 is 6. Let's see what is factorial of 10. Okay. Surprisingly, it is very big number. Let's try factorial of 13. It's also a huge number. Let's try factorial of 15. And let's try factorial of 20. You see, so you see that it's very, very fastly growing function. So you change your input just a bit and adds up to change it a lot. Okay, now let's create a recursive factorial. So def factorial recursive. So the idea is that we are going to use a property that if you look carefully to your formula, you can find that if you look at it carefully, we can find a property -2 times 1. You see, this is a formula of our factorial. So if we can rewrite it a little bit, which is equal to n, and then all this part we are going to put into parentheses. Okay. So, and what we can see from here is that this one is also a factorial, right? So it is equal to n times n minus 1 factorial. Okay. So we just need to program this part. So try to think how to program it. So I'm shorting the formula. So, and basically we need this one. So what we need to do, we need to return something. And we need to return this part. How to do this? So the correct answer is that we can use our function recursively, right? So what do you think? Are we ready to? Are we ready, or is this function miss something? Not ready. Yeah, this function is not ready because, yeah, we need a base case. Yes, absolutely. So what we need to have, we need to check for a base case, and our base case, if n is equal to 1, we need to return 1. And now we are ready. So let's load our function. And let's check it. Factorial recursive. Recursive 20. Actually, the same number. What do you think? Is it an efficient function? We need to tell them to stop. Exactly. So we need a base case that we just programmed. So basically, this function is efficient as the previous one in terms of running time. However, it requires storing intermediate, I wouldn't say intermediate results. So since it calls itself frequently, it needs to store all this backlog before giving us the final results. And of course, there are techniques to do it more efficiently, but it's not for this course. Okay. Okay, we did this. There is some other exercises for you that you can do at home. And before we proceed to our next topic, let's create a function that checks if two lists have at least one element in common. So you just need in your code create two lists by using square brackets. So just let me create it for you. So it's like L1 equal 1, 2, 3, 4. And L2, which is equal 7, 6, 5, 4. And what you need to write a function. So let's like is, for example, is common. Something like that. And L1 and L2. And to write this function, we need to define it. So I'm defining is common there, L1, L2, and it should return whether true or false. So in one case, it should return true if it has common element. In another case, it should return false. Okay. How do you know? How do you know when you need to create a new code line? Actually, I don't need to create a new code line. So what I can do, I can even join all these cells in one code. I'm creating new line just when I want to execute some separate chunks of code, and this is big convenience of notebook, of Python notebook, that I can separate chunks of code and run them independently. So basically, when I need to run some code, if I define some function and I want it to be loaded in the system, because if it's not loaded in the Python system, I cannot call it, right? But basically, everything can be just one script. So there is no need to separate everything. It's just a convenience. Okay, so let's try to solve it. So we need the brute force solution is the following. We just need to go through all elements in L1 and check if we have these elements in L2. Okay, and if we have it, we just return true. Otherwise, we return false. And you see that if okay, I will explain you something a little bit later. So we have a question. Are you missing a call? Yes. So okay, let's try to do that. So yes, we have element in common. But let's change our L1 and L2 a little bit. So now L2 has 1. So they have the first element in common. And what is interesting in our code that this return will work on the very first iteration. So let's try to print how many times we are there. Print some I, right? So just, it's a debugging message. By the way, it's a good debugging technique. If you want to figure out something, how your code working, use prints, okay? So let's see when it's how okay, why it's okay, you see, I forget to load my new arrays. So you see that we were here only once, right? And right after that, it returned true, just because we needed only one iteration to check if we have elements. So that means that this return breaks that cycle. So it worked like breaking cycle. Okay. And this is why we can easily return false here, because this is going only happen if this chunk of code never worked. Okay. So now let's reload it. So let's return it back to 7. So let's see how many iterations we need now, right? We need to go through all the elements in L1. So, and let's see what will happen if we don't have any common elements. Okay, it's false. Okay, we have a question. It's a good question. If you write return 1, will it also return true? Actually, no. It will return 1, and so there is it. So Python is dynamic program, a dynamic language. So you don't know a priori which value, what type of values is going to be in any of your variables. It is both benefits and it's also bad for Python. Benefits is that you don't have to worry much about typing, which is very convenient. But drawbacks is that your code becomes less controllable, you lose control, and it is slow because of that. So you know that the non-dynamic programming languages, they have more control, but you need to compile them. And as a benefit of non-dynamic languages, is they can implement code much faster, right? Because they know in advance which variable is going to contain what value, and that gives it flexibility. Okay. Oh, not flexibility, but it gives it more certainty. But it's a little bit off topic, but actually it's a good question. Yeah. So. E. So the question, does E stands for elements? E is just a variable that I have just created here inside my for loop. And I can then use this variable to make some checks. And yes, it's how this for loop is working. It's just iterating over all elements inside the collection. And in our case, collection is a list. Okay. So now we are ready to discuss sets and dictionaries. Okay, so what is set? So sets and dictionaries are advanced data types in Python. And actually they used a lot because of their efficiency. And since we do not touch code complexity or running time complexity, we are not going to discuss exactly what efficiency means. However, there are theorems that prove this data shapes are very efficient for some types of operations. Okay. What are sets? Sets are used to store multiple items in a single variable. Set is an ordered collection. So you see that in the list we have all elements had their order. Sets doesn't have any order, so it works more like mathematical sets. And all elements in the set should be unique and immutable. So remember that we talked about immutability, and what this basically means is that you cannot change elements inside the set. So what you can do is remove elements from the set and add another, but not to change the element that is inside. Okay. And sets support all mathematical operations like union, intersection, symmetric difference. And what is good about them is that they are fast in finding elements. So imagine list. To find an element in the list, you need to iterate. So suppose we have a list here, right? And to find if 4 is there, for list, we have to iterate from the beginning to the end. For sets, we don't have to do that. They have theoretically proven technique that it can do it very fast. So it can fast the address of the element. For example, if you ask if 4 there inside the set, it has some tricks to say you very fast if it's there or not. Okay, but this topic is related to data types, and we are not going to discuss it there. Here we just know that it has this property. Okay, so how to determine a set? So set, if we change the curves here, change the brackets here from square to curvy brackets, it is going to be set now. Okay, so we have two sets here instead of leads, and we can print them. So L1 is set, L2 is also set, right? So, but you see, while I have set it to equal elements, it is removed here because set cannot have copies of the elements, and order didn't preserve because basically set is not order. And we can even have an intersection of this set, for example, so L2 and L1. So you see it's an empty set because they do not have common elements. But if I change it, so you see they have one element in common. So sets also can have elements of different type. So there are different types. There is, except of intersections, there is operation of union. So union gives a set that has both elements. The difference, operations that give elements from the first set that do not appear in the second set. and there can be a symmetric difference. Okay. So the trick that allows us to find element fastly in the set is called a hash function. So basically, set is an array inside it, but you know that array has index and value, right? But our set has only keys, right? So hash function allows us to efficiently find the index where we should store our key. So as a result, in our array, the elements with a similar case key will be, how to say, metaphorically, they will be near the same place. And actually, there are elements that may have the same key. They will be stored in this array just one after another. And so we don't, to find element by key here, we don't need to go from the beginning. What we need to do, we just need to calculate a hash function and then look just in the index that hash function gives us. So as a result, we don't need to check all arrays, but maybe just some elements of the array. That's why it's fast. And there is a theory behind that. Okay. So we can add elements into set, we can remove elements from the set, but what we cannot do, we cannot add arrays to the set. So you see, if I try, so I can, so let me create a new chunk of code. Now I create a new chunk of code just because I want to have a clear space. So L1 add, for example, 10, right? So I can implement that. And now let's see what this L1 is about. So L1 now has element 10. Let's try to add, and I said that you can add elements of different time in the same set. Let's try to add some array just of one element with 0. Oops. You see, it says that type list is unhashable. And why it's unhashable? It's because it's mutable, because we can change this list. And if we change this list, that means that the hash is going to change and it causes a problem for the set. So the immutable version of set called tuples or tuples, so, and tuples, to get a tuple, we need to change, square brackets to round brackets. And now it's going to work. Let's see what's our L1 have. It have tuple. Okay, tuple of 1 is just a number. Let's do this one. Okay. Yeah, you see now it has a tuple here. Okay. And tuples are very similar to arrays. So let's compare arrays and tuples. Here is our array that we can modify. And let's create a tuple, similar one that we cannot modify. So they work very similarly. We can access elements by index. So you can print B. So here's a B. So it has 4 elements like A. A also has 4 elements. We can access B by index. Okay, we can iterate B print I. Yeah, we can enumerate like we did with list. But what we cannot do with tuples is we cannot change it. So B2 equal to 3. We cannot change even single element inside the tuples because it doesn't support assignment iteration. Okay, we have a question. Okay. That's it about sets. So we discuss it. And now is a short question. Write a function, solves the previous problem. So create a function that checks if two lists have at least one element in common that uses sets. Okay. And here's a question for you. Why it's more efficient than the previous version of solution for this code with lists? Okay, let me jump in straight away because we are running out of time. So here is our second function. Where was my previous one? Okay, never mind. So let's create a function. So it's def s comma 1 L2. So what we need to do is we just I have forgotten to tell you how to convert lists to sets. So it's just a set function like we did with float, integer, string, str. So to convert list to set, we use set function, and to convert, so it's L1. Then we have S2, which is equal to set S L2, and we need just return okay, I'm not going to use shortcuts. So if S1 and S2 return true, else return false. Okay. So let's recreate our L1 back to arrays. And just as common L1, L2. Okay, it's true. Let's remove this 4. Yeah, everything is working. And it is more efficient than previous iteration, than previous version. Where is the previous one? Cannot find it. Okay. I will explain it. So remember that we used the function if, for example, for in L1. So this in is not efficient. So it is going to go from the beginning to the end. And as a result, in our previous function, we had a double loop. Think about that. So you really, while you think you have if here, but because this one is going to iterate through all the elements, it's equal by time spent to implement this operation is equal to the whole for loop. So as a result, we have a double for loop. But because here we have a set, we don't have this double for loop. Of course, we need to go from the first element to the last here, from first to the last here, and this one is also requires for loop, but it is not double for loop. Okay, and I will tell you that double for loop is worse than a single for loop. Okay. So what's next? So let's have a break for 10 minutes and let's meet at 3:40. Yes, it's more efficient because it doesn't need the second for loop. So remember when we printed a multiplication table, it has a lot of elements. It's like n times n element, and the same happens with iteration. We need n times n operations to get the results. Here, and it's a property of double for loop. Here, when we're using set, we skip inner for loop, and as a result, it becomes more efficient. So basically, it's a little bit trickier question, and we didn't touch much to answer it, unfortunately. But I just wanted to give you an idea about thinking a little bit that maybe different versions of algorithm may get results faster or slower. So basically, you just think here, there is think. So you need to think about it a little bit just to test your intuition, because we didn't touch this complexity at all, unfortunately. Yeah, but we can still test our intuition. Okay, see you at 3:40. Okay, let's continue our lesson. And actually, we're almost done, so we have only 1 hour. And we learned a lot for these 3 days. Yeah. So a little bit more advanced techniques, and a little bit more advanced set is dictionary. So what is difference between, what is main drawback of sets? So is that you can hold, you can only access keys of the set or elements of the set fastly. So, and you cannot access anything related to that, and you cannot modify sets. And dictionaries is a little bit extended version of the set. So because they can store not only keys, but they can store key value pairs. They also use hasset for keys, and therefore they're very efficient in finding elements. So here is an example of set. So it's characteristic of some person, I don't know, in an organization, and so on and so forth. And so let's create some set here. So some dictionary. So basically, dictionary also is created with using curly brackets, right? But since they have key value pairs, so you need to set them somehow. And to setting it, you use separators, which is columns. So the left side of separators is a key, and the right side of separators is value. And value can be anything, as well as a key. So for example, I can even use the word key and use the word value or key one, and set number 1. So here is my toy dictionary, and I can very efficiently have access to elements. How do I have access to element? I use square brackets as I used it in arrays, in strings, but instead of index, I put here my key value. So for example, D1 is going to be equal empty set, right? So I don't have an element with index 0 here, and that's why I have an error. I can set element with index 0 to something. So even if I don't have it, I can set it, and it will create another key value pair. Okay, and now I can access this D0 element. Okay, so let's try to print this dictionary. So it looks the same as we set it, right? So it has a set of key values pairs. Okay. Yeah, we can separately extract keys from here. It will give us only keys. And we can iterate through the keys. So for key in the keys, we can print all the values. We can extract values directly. Values. Okay. So this is a very short introduction to the keys. And I just give you an idea how to work with them. So, and here's an example how I'm going to use a set. So you're given n numbers, say a1 through an, output all the modes of this list on a single line. Okay. So we have a list which is equal, for example, 1, 2, 0, then again 1, then 2, 1, then 2, then 4, right? So we need to print all the mode of this list, and mode of this list is the element that has a higher frequency here. And what does it mean, all the modes? Because we can have more than one such element. For example, we have one here 3 times and 2 also 3 times. So we have 2 modes here. Okay, let's create a function that prints the modes. So let's define a first function is going to be find modes that accept list. And how we are going to find the modes? We want to do it efficiently. So first we need to create dictionary. And by using property, the dict has not only keys, but also values. We can store frequencies as values, right? For that, we need to iterate from each element in our list and check if E in D, so if element in our dictionary, and we know that it's very efficient operation because we're using hash function inside dictionaries to find element, and if it's inside the if element is inside the dictionary, we modify the value of this key, or of the pair that associated with this key. So D plus equal 1. Okay. Otherwise, so if no element in our dictionary yet, we just create this element because we met it in our list and set its frequency to 1. Okay. Now we need to find max value. So max value equal find max value. So I'm going to use top-down approach and D dot values. Okay. And after that, I just need to in a cycle through all keys for E in dict if dict E. So I'm checking if value of element E is equal to maximum frequency or maximum value. Then I just print this key. Okay. Now I need to define another function, which is the max value. All these functions actually are inside the Python, but and you can do it more efficiently. But I'm trying to show you, and basically what I'm creating, it's exactly the same code that's already created inside the Python libraries. So, and basically there is almost any functionality, I mean basic functionality that you're going to create, it's has like 99% chances that it's already created. But here we're learning how to program, so we are inventing our wheels each time. Okay, so we are going to find our max value inside the array, because G value gives us some collections that is very similar to array. So how to find max element in the array? We know that our elements are frequencies. So the minimum frequency is going to be actually 1, right? In our values. And here for in else, if E is greater or equal than our maximum element, we just substitute our max element with element. And after we checked all the elements in our correction, we just return maximum element. Okay. So I hope that we are ready with our two functions. And now I'm calling find modes with our list. Yeah, we have two modes, 1 and 2. To print them in one line, we need to change ending here to, okay, let's print them over comma. Okay, and however, we can improve it forever. And to make our function more general, let's create the list with the results. And instead of printing, we are going to add elements to our results and append E and return this results at the end, and then just print this array. What is some none here? Okay, whatever. There is some bug and we don't have time to fix it. Okay. But I believe that you get the idea. So here is an exercise for you that I think you better to do at home. And let's move to our last topic, which is about libraries. So libraries are external codes that developers can use for their tools. As I said, so we have, during this course, we were inventing wheels all the time. And the majority of codes that we have created during this course, it's already here. And we just need to know, just get an idea how to find this library. So first idea is that we know that a lot of code is created, and that code is separated into libraries, and each library is specific for some close related tasks. And we just need to visit Google or to find it on Stack Overflow or use help of libraries, trying to understand the library and its functionality and try to find the functions that we need. And basically, in Stack Overflow, there is a lot of best practices already posted how to do certain tasks. And so it's a good place to find the solutions. What is good about libraries is that they already contain complex data types, functions for advanced mathematics, for data analysis, for machine learning, for web parsing, actually for everything that computer does for us. So, and there are some useful libraries that are systems, math, NumPy, pandas, matplotlib. So you can Google any of them and read about them. Okay. So we can even create our own models or our own libraries. So, let's put our say hello function to library. So for these purposes, we are going to use to write a file, actually to write a script in our system. So let's, so how to do that? We are going to use multi-line string and just type a function in here. So define, say, hello, who, and then just use print hello format. Okay, so we have written a function, and we can now we can write it into the file. So we know how to write into the file with open our script. We need to find. We need to. Since we are going to create our library, we need to set to choose, pick a name for that. So let's call it my library dot py, because Python code is going to have extension py. And don't forget to write and to open it in the writing mode. Don't forget to set it a name, and then f dot write our code. So, and now we have a script. Not Okay. Okay, good. Now our system have to have a file inside. So let's check it using our magic functions that we used before. I just want to remember that we're working on the Linux system, and we can call all Unix command from there by just using this magic magic functions. So in EC we have my library here. So now, since we have it in the system, let's just import that. Import my library. Okay. And now we have imported our code here, and we can use our code from our library. So my library dot, and now we have a function here, and you see it in, it understands what function we are talking about. Say hello, then let's say Bob. Okay, everything working. Okay, that's it about libraries. So what libraries do we have? We have a lot of libraries, and it is just a short list. So sys library is for system utilities that closely works with your operating system. We have a library for that implements an interface with your operating system. We have a library for mathematics operation. We have a library for linear algebra, which is NumPy. We have a library for working with tables in CSV format or Excel format, which is Pandas. So basically you can, if you're working with Excel, you can automatize everything using Pandas, and you can create all types of analytics. Actually, you can work with your Excel file like with databases. So using this library, then you have Matplotlib and Seaborn functions that are widely used to create graphics for your articles, reports. Yeah. Okay. So how to use this function libraries that are already here? So first of all, you need to install them, but you can always look into user guides and helps how to install your functions. There is nothing hard there. And you importing after you install them, and many of the libraries are already installed, like libraries like this, and you just put it import sys like we did, and you can use it. So for example, you can call system, or how's it called, version info, and what it tells to you, it tells the version. Oh, it's not callable, it's just an object. Okay, it has the information about your Python. So we're working here in Python 3.7.12. Okay, and this has a lot of other informations. You can, for example, find information about float on your system, about integer in your system. You can check what platform you're working in. And you can use dir just to list all the functions that your sys library have. There is math library that you can, so there's also a lot of functions like greatest common divisor, like logarithm, like trigonometric functions. Very useful function is random, so you can use it. So for example, there's a function random, so let's import random import random, and you can use it to generate random numbers. Yeah. Each time you call it, it has different random numbers. Yeah. Then you have random choice. So if you have a list, you can randomly pick any element of your list. Yeah. Each time I press the button, it picks different element. Sometimes they repeat, but it is a random function. So, and here is seeding function. What I was trying to show here, that we can set a seed, which is sometimes useful for debugging or for reproducibility of the result. You see, we have two loops here, one outer loop and one inner loop. So for outer loop, we form the row here, and each time we start the row, we reset our seed to a certain number. And you see, while each run has its own random variables, but because we set seed to the same value each time, so every single run is a repeat of the same random variables. Okay, and if we use different seed, we have different series of random numbers. So it allows us at the same time to have consistency if, for example, we're testing something, or if we rely on some simulator and we want to repeat the results, but at another time it is still a series of some random values. Actually, it is not pure random, but however, it's called pseudo-random functions, but you shouldn't be scared about the word pseudo. They are pretty accurate, and they is pretty accurate in producing almost ideal random distribution of the kind that you are going to use for your analysis, for example. Okay. So here is the exercise for you. So you need to write a program that asks users for his or her favorite fruits and then propose a random fruit from user's input. So ask user to input fruit one by one in a while cycle and store user's input into array. Use random choice to recommend the fruit. Okay. So don't forget to import your library. Okay. Okay, let's write this function to this program together. So what we need to do, first of all, we need to import our random function. Then I would like to go top-down approach, and I want to call a function that's called read users input. And I don't have this function yet. Let's define it. Read users input, and just make a funny, so return something. So just using the top-down approach that we discussed before. So this is not real function, but just a prototype. Okay. So, and since it returns an array, we need to have some variable. So user fruits, which is equal to read user input. And then I just need to use random dot choice from user fruits, and I just need to print it. Print and okay, it works, but let's now make this function real. So we need to create a variable user fruits, which is just list, and then while true, we ask user to provide his favorite fruit, and input is your fruit. Okay. Actually, we need to stop somewhere, because now it's going to work infinitely. So that's why we need to create a variable for checking. So if fruit, if not fruit, then we just return. Okay, it is going to work. Let's check. So banana, tomato, orange, and nothing. Okay, so it looks like it works. Any questions so far? Okay. And the last topic is about running scripts. So, as I said, we're working on, when we're working in Notebook, we're working under some system, and on Google Colab, we're working under some Linux machine. It's going to be some virtual machine. And I can run Python from here, basically, by using my magic command. Now you see, so I just called Python, and that actually means that I can run some scripts out of here. So let's create some script with open my script.py And let's write it. Let's write something, for example, f dot write. Let's print something. Print. Let's write a hello world here. Print. Hello world. Okay. Yeah, we need to write it. We need to open it in writing mode. Okay, let's check if we have the script in our system. Yes, we have it. And now let's call it. Okay, yeah, everything is working. So, and as you know that you can to many programs you can provide parameters, and we can read these parameters using systems argv, using library systems and checking argv array. Okay, so let's try this. So import this, and since notebook, this Python notebook is a program that we are working in, it also was run by somebody or by some script at startup. Okay, so we can check what was the command line that started this process. Okay, so let's check, and you know that the first argument is going to tell us in our parameters is going to tell us how command line was run. So you see, we are working under some scripts which called IP kernel launcher py. So actually, we are working inside some Python scripts that reading our input, that providing us results of our input. So like we did with our, we created, basically what we were doing, we were reinventing the wheel when we interacting with user. So, and basically these programs that we're working on can also interact with user if we run this IPython kernel launcher with some properties. Okay, let's check all arguments that we used to run the script. You see, there is kernel that we used, and there is some file that was provided to set up our session. Okay, let's try to do the same for our script. So for these purposes, we need to create a script and to read our arguments. So let's do that. First, we need to, so here's an example. Write a program that accepts two integers x and y from user and prints x squared plus y on the display. Okay, let's try. Let's do that. So first of all, let's create our program. My script equal, and let's use multi-line. So, and here we're just writing a regular script. So arg. So a equal, first we need to import system inside our script. Import sys a sys.arg v1 and b equal sys.arg v2. Okay, well, for simplicity, we're going to use two arguments. Okay. So, and let's print it. Print a square plus b. Okay, here's our script. Let's write it to our actual script. So with open script 2.py in writing mode, and then as f dot write my script, and now we have our script that is ready to be run with arguments. Let's try it. Item 3. We need to call our script item 3 my script 2.py and provide it to arguments. Okay. I forget that we need to convert our variables before implementing arithmetical operations. So let's fix this error. Okay, let's check. So you see, it is working. So we have run our script with arguments. Yeah. And additionally, we can check how do we call this script. Okay, so let's print 0 arguments. So sys arg v0. Okay, just do it like that. See what will happen. Okay, and indeed we call this script with using it as a first argument. So here is exercise for you. Write a program that accepts user favorites fruits as a script arguments. So instead of 5, 4, you just need to list fruits, and then random. You need to propose a random fruit from user's input. Okay. So what you need to do is just basically modify the script and iterate through the arguments. So guys, how many of you are going to work on this exercise right now? Or you're tired, guys? Because if you're not going to work on it, I will show you the solution and then we will discuss the homework. Okay, so let's modify the script first. So we know that user is going to provide us fruits as arguments, one fruit for one argument starting from one, because zeros argument is reserved. So what we need to do is just create a list here. So it's list, and then just add users arguments here in a cycle. So for E in range 1, because we start with 1, there is result, as I said, len sys.arg. Okay. And for each index, we need to add its argument into the list. F equal, f dot append sys dot arg v. Okay, and that's it. Then what we need to do is just yeah, and I forgot to import random here. So import random here. And the last thing, we just need to print a random choice of our fruits. So random.choice f. Okay, let's see. Let's call it my script 3, and let's run it. So what are going to be my fruits? Banana, tomato, orange. Okay, let's try. Choice is misspelled. Okay. It is working. So now we know how to write scripts from scripts and run scripts from scripts. So basically, you're going to be much advanced now, especially if you solved or going to solve all the exercise and examples. Okay, so now let's discuss our homework. So first of all, a quiz is uploaded to our Google Drive, and graded homework is here in the end of the slide. So basically, what is this task about? So every morning we have to make a decision about what we want to eat. And to simplify our task, we decided to delegate this decision to a computer. We have created a database which consists of 7 files, one for each day in the week, right? So we have some food for Monday, for Tuesday, for Wednesday, and for Sunday, where each file has a list of choices of food for the corresponding day. And there is another file called refrigerator.txt that contains a list of available food. So you see, you have two things. So first is a list of preferred food, and the second is a list of available food. And your goal is to write a program that creates a meal plan for the next n weeks as a table with 3 columns. So as the output of your program is a meal plan, as a meal plan for several numbers of weeks. So it's going to be a table with 3 columns. Okay, and here is the format. So input file format is meal choices for each day, and the refrigerator that keeps only available fruits. And here's your output. So for each week, for each day, you need to pick some food. Okay. So the n parameter you need to pick how you're going to input it into your program. So there are two choices, whether to ask user or to pass it as a parameter. So both variants work, okay? So that's it. Thank you very much, and I hope I helped you. Do you have any questions?
How do we turn in the homework and the quiz?
Just send me an email with both your homework and quiz, and please send me it by the next Friday. Any other questions? Okay, you're welcome.
Yes. You can stop recording.
Do we have a later grade for the workshop?
You can stop recording.